Welcome to my video lecture based on network analysis technique. Myself Roman Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Shubhit Chandra Degree Engineering College. In my previous lecture based on circuit theory, different basic laws, source transformation technique, independent dependent sources and basic laws I have already discussed. In this lecture, we will see how the network analysis can be done by using some different tools, by using some different laws, and how the network analysis can be done with basic law and its implementation techniques. So here I will mainly briefly discuss on loop analysis and node analysis technique, which is based on Kirchhoff's current law and Kirchhoff's voltage law. So now I will continue with my lecture of network analysis technique. So here, network analysis techniques is the determination of response of output of a network when the input excitation is given. That means, suppose some voltage, current, resistance, capacitance, inductance, like those values are given, and we have to find some unknown parameters with help of different mathematical calculation and with help of some laws. There are two techniques of network analysis. These are two basic techniques for network analysis. First one is nodal analysis and second one is loop or mesh analysis. In nodal analysis technique, it is based on Kirchhoff's current law, KCL. In this method, the unknown variables are node voltages. It is generally used when the circuit contains several current sources. When circuit contains several current sources, then it is very much helpful if we use KCL. So first step is, if there is n number of nodes in a network, node means the junction points, all the nodes are labeled. One node is treated as datum or reference node. That means this is basically zero potential or ground. And other node voltages are treated as unknown to be determined with respect to the reference point. KCL is written at each node in terms of node voltages. KCL is applied at n-1 nodes of n nodes of the circuit using assumed current direction as necessary. By calculating with KCL Kirchhoff's current law, first we have to identify the current direction as per the conventional way. This will create n-1 linearly independent equations, and those are known as basically node equations. That means by using the current direction by applying Kirchhoff's current law in different nodes, we can form different equations. Now by solving those equations mathematically, we can calculate different node voltages. In a circuit with independent voltage source, if two nodes of interest are separately by a voltage source instead of a resistor or current source, then the concept of supernode is used. That creates constant equations. The current is computed based on voltage difference between two nodes. The current in any branch is obtained via Ohm's law. That means if we want to determine the current between P and M, then it will be Vm minus Vm divided by R for DC. And if it is AC, then it will be Vm minus Vm by Z. Here Z is the impedance. Next, solution of n-1 simultaneous equations by using Gauss elimination techniques or matrix method, we can calculate unknown node voltages. Next is concept of supernode. This concept is used when a circuit contains voltage source. A supernode is formed by enclosing a dependent or independent voltage source connected between two non-reference nodes, and any element connected in parallel. This concept is necessary for nodal analysis with voltage source. Because the current through the voltage source is unknown, we have to consider mainly two cases. Case 1, when the voltage source is connected between the reference node and non-reference node. In this case, the voltage of the non-reference node is taken equal to the voltage of the voltage source. For this case, this is the circuit. Here, voltage V1 we will taken as 5 volt. See, that this is the voltage V1, and here we will consider that voltage is 5 volts, because the voltage of non-reference node is taken equal to the voltage of the voltage source. Case 2. When a voltage source is connected between two non-reference nodes. In this case, a supernode is considered enclosing the non-reference node. Both KCL and KVL is written for supernode case. So here, see, this is second example where V2 and V3, in both cases the reference voltage is taken as 10 volt. Now, for example, node 2 and 3 are forming the supernode. This is node 2 and this is node 3. These two are forming the supernode. Now, by applying KCL at supernode, definitely I1, this is I1, it will be combination of voltage going out, that means I1 plus I3. These two voltages are leaving and our I1 is entering, that means I1 equals to I2 plus I3. So putting these values, this I1 will be definitely V1 minus V2 by 5, then V2 by 10, then it will be V2 minus V3 minus 0 by 20. Here 10 volt is basically supernode. To applying KVL to the supernode, the circuit will be drawn as current 2.2B like this. Here 10 volt is the supernode case, so applying KVL here, it will be 10 plus V3 minus V2 equals to 0. That means V2 minus V3 is basically 10. Now, using these two equations, we can calculate the values of V1, V2 and V3. So, here 10 volt which is connected between two nodes, or voltage source which is connected between two nodes, is considered as reference supernode. Now, properties of supernode. It provides constant equations. Second, KCL and KVL are written for supernode, and the supernode does not have any voltage of its own. Okay. Now, next one is loop or mesh analysis. It is basically based on Kirchhoff's voltage law KVL. In this method, the unknown variables are loop currents. It is generally used when the circuit contains several voltage sources. If there is n number of loops or meshes in a network, all loops are labeled. KVL is written at each loop or mesh in terms of loop or mesh currents. Loop currents are those the currents flowing in a loop. They are used to define branch currents. Now, for n independent loops, total n equations are written using KVL around each loop. Second, the concept of supermesh is used in case of circuits contain current source that provides the constant equations. Now, solution of the n simultaneous equations gives the required loop or mesh current. That means by using Kirchhoff's current law in node analysis, we can calculate the node voltage at once, and by using Kirchhoff's voltage law, in applying mesh analysis, we can calculate the mesh or loop currents at once. Now, concept of supermesh in case of Kirchhoff's voltage law. This concept is used when the circuit contains current sources. Previous circuit contains voltage sources. Now, if circuit contains current sources, then we can apply supermesh. A supermesh is formed by excluding the branch containing a dependent or independent current sources connected in common two meshes, and any element connected in series with it. Here, the current I2, this is connected with this loop 2, and it is connected with a resistance in series. This concept is necessary for loop analysis with current source because the voltage drop across the current source is unknown. Now, case 1, when a current source is in one mesh. For this case, it is connected in one mesh only and one series resistance is here. So, in this case, mesh current is taken equal to the current source, because in this case, in second loop, this 10 ampere current is connected with a series resistance. That means we will ignore this part and we will consider that the current source 10 ampere is flowing in this loop. As the direction is opposite, so we are taking it as minus 10 ampere. Okay, we have taken the loop current direction this direction, and the current is already given in opposite direction, so this loop current is 10 ampere but it is negative. Second case, when the current source is connected between two meshes. See here, this current source 3 ampere is connected between loop 3 and loop 1. In this case, a supermesh is considered excluding the branch with current source and any element connected in series with it. Here, 1 ampere is connected in series with 3 ampere. 1 ohm is connected with 3 ampere current source. And both KCL and KVL is written for supermesh. For example, consider this one, that supermesh is formed by excluding the branch of 3 ampere current sources. We are excluding this branch of 3 ampere current source. By applying KVL for supermesh, definitely it will be 2 into I1 minus I2 plus 4 into I3 minus I2 plus 8 I3. Okay. Now, by applying KCL at any node, suppose it will be I1 equals to, this is I1 equals to 3 plus I3. Now, applying KVL in second mesh, we will get 2I2 plus 4 into I2 minus I3 plus 2 into I2 minus I1 equals to 3. Solving equation 1, 2 and 3, we can get the mesh currents like this. This is the concept of supermesh. The property of supermesh like this, it provides constant equation. Both KCL and KVLs are written in supermesh, and supermesh does not have any current of its own. So, up to that is for supermesh concept. Now I will come to duality concept. Duality is a transformation in which currents and voltages are interchanged. Two phenomena are said to be dual if they are described by equation of the same mathematical form. There are a number of similarities and analogies between the two circuit analysis techniques are based on loop current method or node voltage method. The principal quantities and concepts involved in these two methods based on KVL and KCL are dual of each other, with voltage variables substituted by current variables, independent loop by dependent node pair, etc. This similarity is termed as principle of duality. Some dual relationships are there where voltage equals to resistance into current R into I, or in dual it is I equals to G into V. Similarly, V equals to L di dt and I equals to C dV. Again, V equals to 1 by C integration I dt and I equals to 1 by L integration d dt. Thus, the circuit elements R, L and C have some dual relationship, and duality also appears as relationship between two networks. For example, an RLC circuit with voltage extension is dual of an RLC parallel circuit with current extension. That means series RLC circuit is dual of parallel RLC circuit with current source. So for series RLC circuit, V equals to Ri plus L di dt plus 1 by C integration I dt, and for parallel circuit, I equals to Gv plus C dV dt plus 1 by L integration V dt. These are the main dual relationships. These are the dual quantities and concepts where current and voltages are dual, resistance and conductance dual, inductance, capacitance dual, impedance and admittance, reactance, susceptance, branch current, branch voltage, mesh or loop, node or node pair, mesh current, loop current, node voltage, node pair voltage, link tree, link current, tree branch voltage, tree branch current, link voltage, tie set, cut set, short circuit, open circuit, parallel path, series path. All these are based on dual quantities and dual concept are based on that. And these all protein parameters, they are just dual with each other. Thank you. Thank you for listening my lecture.